Hello everyone and welcome in a new video. In this video, we are going to understand about Banker's algorithm. Okay. So for understanding Banker's algorithm, first of all, we need to understand that what is it basically. So Banker's algorithm is the algorithm which checks our system is in a safe state or not. A system is in a safe state or not in a safe state. So Banker's algorithm is a resource allocation, or you can see a deadlock avoidance algorithm which test for the safety so the bankers algorithm is a resource allocation and deadlock avoidance algorithm that test that okay, so that test for the safety it basically checks and give that a system is in a safe state or not. How to check? We see this thing with the help of a numerical, but Banker algorithm it basically deadlock avoidance algorithm. It avoids the deadlock. It tests it tests for the safety. Okay. So there are some requirements to for a Banker algorithm. What are the requirements? The requirement is basically the process need to initially told us that how much resource it needed to complete their execution. This is what the process have to told to the operating system that okay, I need this much resource, and if it say, then we can apply Penkel algorithm. Okay, so these are the requirement. Every process must announce the maximum number of instances of each resource before the process start execution. Before the process start execution. This is what process have to told initially about the maximum number of instances. Okay, but if you think this deeply, that how a process can know that okay, this was resource we need. Initially, a process cannot know that okay, I need this much resource, I need that much resource. Okay, you cannot predict initially that how much resource a process needed. So if you cannot predict, you cannot provide. If you cannot provide, so there is no practical implementation. So Banker algorithm is no practical implementation. It's a theoretical concept. Okay. So it is practically not possible. It is practically not possible. Okay. So I hope you understand. I made it in a red. So you remember that it is practically impossible. Okay, so this is what a Baker level was. Now, let's solve the question. Let's solve the question. Okay, so we have a question. We have a process, allocation, maximum, and an available. So, okay, so these are the prerequisites. We understand now solve it. So, solving this question, we need to understand about the allocation, max, and available. So, we know about the process. We discussed so many times about the process. Now, the allocation. What is allocation? Allocation means already allocated a process. Already allocated process already allocated uh, to process already allocated resource to the process. So P1 already have one resource instance, P2 already have 5, P3 have 3, and P4 have 2. So these are the resource which these process already have. Maximum means maximum number of instance of a resource needed to start the execution. If P1 get 3 resource, it start the execution. P2 get 8, it P2 start execution. P3 has 4, it is start. P4 has 7, it is start. So maximum means maximum number of instance of resource needed needed to a process to start the execution. So process for execution. So this is what a maximum it did. Available. Available means number of available instance of a resource in a system. Only one resource is available in a system to fulfill the requirement. If it is able to fulfill the requirement of the process, then we can say that the system is in a safe state. And if it not, one resource are not sufficient to start any of the processes, then we can say that the system occur deadlock. Deadlock basically occur in the system. Okay. So number of available instance. Available means number of available instance of resource in system. Okay. So these are the pretty much things that needed to understand. Now solve the question. Okay. So solving this question, okay, so what I can do is, okay, so now let's solve this question. So how to solve this question? Available means the system basically have one resource, and if one resource is satisfy any of the following process, you provide that resource to particular process, and that process start execution and completed, the process can terminate. And whatever the important point is, whatever the allocation of that resource, whatever the resource allocated to that particular process is also free. Let's see what I basically told you. That first of all, we need to find need. What is a need? Need is a maximum minus the allocation. Maximum minus allocation. Maximum P1 need 3. It already have 1. So how much it needed? It needed 2. Simple one. Same with P2. 8 it needed, 5 already have, so it need 3 new resource. P3 need 1 resource instance, and a P4 need 5 resource instance. So these are the needed items, needed resource. So we calculate needed. Now, does any one of the processes satisfy with the available resource? We have to check that any of these processes can satisfy with the available resource. So the answer is yes. Available we have 1, and we can satisfy one resource, which is P3. If it is, then satisfy that resource. So now this available resource instance is provided to P3. So now P3 have 1. So needed item is what? 0 now. P3 start execution. P3 start execution. When P3 is completed, when P3 is completed, it release all the resource. It release all the resource, the available one and the allocation one. Okay, the available one and the allocation one. So let's understand in a descriptive way that, okay, so P3, we provide the available resource to P3, P3 start execution. So after P3 is completed, now what is a available resource for a particular system? Now we need to calculate this, because we need to satisfy all the process. If we satisfy all the process, then we can say that, then only we can say that system is not having a deadlock. Okay, so P1 is completed. Now the available resources are, how to calculate this? Available of P3 added the allocation one. Sorry, available. Okay, so you can write it like available resource plus the allocation of P3. So how much resources available initially? We have one. Oh, we have one resource available. Now, what is the allocation resource of P3, which is 3? So now, new available after completion of a P3 is 4. New available resource after completion of a P3 is 4. So after P3, the available resource is 4. After P3, the available resource is 4. I hope you understand this thing. The easy one. Okay. After that, now P3 is completed. P3 is complete. So P3 is done. Now, available resource instance can satisfy any of the process. So the answer is yes, it satisfies two process P1 and P2. P1 need 2, P2 need 3. So you can provide any one of them. Okay. So there is not a particular procedure, a particular way to provide the available resource. You can provide to any of these processes. Okay. So let's say we provide it to P1. Let's provide it to P1. Okay. So P1 get process, P1 needed 2. So we have 4, it need 2. So we provide 2 resource instance to P1. Now P1 start execution. P1 start execution. So when P1 is completed means after P1, what is the available resource in a system? How to calculate the available one? Currently available one, we have 4. Okay, so currently available one. So I can So the currently available one, which we have 4 right now. Right now we have 4, and the allocation of P1. P1 is having 1. So 4 plus the allocation of P1, which is 1. So 4 plus 1, which is 5. Now after completion of a P1, after P1, we have 5 resource available. Now P1 is also completed. We have 5 resource instance available to satisfy the other process. Now, we can again satisfy both the processes P2 and P4. We can satisfy both the processes. So, let's see, you can satisfy any one of them. I go with P2. Okay. So now, P2 needed 3. We have 5. So, we provide 3 resource instance to P2. So, now P2 start execution. After completion of a P2, after P2, now what is the available one? What is the available resource? How to calculate? The currently available value, which is what 5, plus the allocation value of that particular process. Allocation of P2. 5 plus what is the allocation value of P2? The allocation value of P2 is what 5. 5 plus 5, it becomes 10. Now, after completion of P2, after P2, we have 10 resource instance available. Now P2 is also completed. We have one process left. Does it satisfy that process? We have 10 resource. We have 10 resource. It needed 5. Yes, we can able to satisfy this requisition. We can able to start this process. So provided the 5 resource instance to that particular process. So P3 is also start executing. Okay. So sorry, P4. P4 start executing. P4 start executing. Now after P4, after P4, what is the available resource? Currently available plus the allocation of P4. So what is the currently available value? Which is this one, 10. 10. Added the allocation value of P4. What is the allocation value of P4? 2. 10 plus 2, which is equal to 12. Now, after P4, we have 12 resource instance available. After P4, we have 12 resource instance available. So, does it satisfy all the processes? Now, all the processes are completed. Yes, the answer is yes, all the processes are completed. If all the processes are completed with the available resource, then we can say that this system is in a safe state. Safe state. This system is in a safe state. Okay. We can say that the system is in a safe state. So I hope you understand that how we calculate, how we check basically the system is in a safe or not. Now, the important thing is, for a gate point of view, it says that what is the safe sequence. The question asks like that, what is the safe sequence? The options are P1, P2, P3, and P4. P2, P1, P4, P3. So option is looking like this. So you have to uh, find out the safe sequence. So that's very easy. What is the sequence you follow? You have to write it that. First of all, we execute P3, then P1. First of all, what we do? We execute P3, then execute P1, then execute P2, and then execute P4. So this is what the sequence we follow. So this is what the safe sequence is. So safe sequence is P3, P1, P2, and P4. So this is what the safe sequences look like. Okay. There are more than one safe sequence for a particular question. In this question, we definitely have more than one safe sequence. We started after P3, we take P1. You can take P2 as well. So the safe sequences change accordingly. Okay. So if you take P2 and then P1, then the safe sequences look like P3, P2, P1, and P4. So this is also a correct answer. This is also a correct answer. So I hope you understand about the banker's algorithm. Okay. So this was an easy question. I hope you understand this. Now let's solve the other question, which is this one. Now, why I say a resource instance initially uh, when we understand this thing, we say that available one. We say that number of available instance. What does this mean? This means that more than one type of resource is available in a particular system. This means three type of resource available. Let's say ABC, ABC, ABC. Okay. So A kind of resource we have P0 already have 0. Allocated 0. B type of resource instance it have 1, and C type of resource instance P0 have 3. Maximum A needed 7 for P0, B instance needed 3, and C instance needed 5. Okay, so more than one resource instance is available in a particular system. We have to provide a particular instance for a particular process. Okay, now this question. Let's solve this question. Pause the video and try to solve this question by yourself. If you are able to do that, then it's well and good. If not, then follow the step. Okay. So first of all, we have to find need. What is the need? Need is maximum minus allocation. Maximum minus allocation. Maximum A needed is 7 for P0. It already have 0. It needed 7, so it definitely needs 0. A type of sorry, it needed 7. It needed 7. So you can write it like A, B, C. So for P0 we need 7 A resource. For B we need 3 it needed. One it already have. So the needed one is what? Okay, so I think I write okay. So correct this question by 0, 1, 0. 0, 1, 0. Okay. Now solve this question. And we are the allocation one we have 5 and 3. This is the question. Okay, this is the question. So, 7, 5, 3. Okay, this is the question. So 5 minus 1, which is 4, 3 minus 0, which basically is 3. Okay, now for the P2, 3 minus 2, it needed 1 A kind of resource. 2 minus 0, it need 2 B kind of resource instance. 2 minus 0, again 2 C instance needed for P1 to start the execution. Coming up with P2, it already have 302, needed 902. If you subtract it, A kind of resource P2 needed is 6. B doesn't need anything, and for the C, it also not needed any kind of C instance. So 600. For P3, 2 minus 2, 0 A needed. 2 minus 1, 1 B instance and 1 C instance as well. P4, 4 minus 0, 4. 4 minus 0, 4. 4 A needed, 3 B needed, and 1 C needed. So this is what the need of this particular process. The need of the particular process. Now let's check what are the available resource we have. We have 332 are the available resource we have. Okay. So does any one of the following processes satisfy with the available one? So the answer is yes. Yes. We can satisfy the P1 process. We can satisfy P1 process. Okay, so because it needed 122 and we have 332, so it's definitely satisfy the P1 process. So if it does, then provide that to P1. Now P1 start executing. You provide the resource, P1 start executing. So after P1, what is the available resource? How to calculate? Available plus the allocation of P1. That's it. So available we have 332. Allocated to P1 is what? The allocation of a P1 is what? 200. 200. Now, the available resource is 632. The available resource is 632. Okay, so 532, not 632, 532. Okay, so after P1, we have resource available is 532 and P1 is completed. P1 is completed. Okay, P1 is done. Now we have 533 resource available. Does any one of the following resource satisfy? Yes, we can satisfy P3. We can satisfy P4 as well. So let's go with P3. Let's go with P3. So now P3 start executing. P3. After P3, when P3 is completed, what is the available resource? What is the available resource? How we can calculate? Available in the system plus the allocated of P3. So available in the system is 532. Allocated to P3 is 211. 211. So overall it becomes 743. 743. So after P3 we have resource available 743. Now P3 is complete. You can see that how easy it is. Okay, so we have resource 743. You can satisfy the first one, the third one, and the fourth one. You can satisfy any. You can satisfy all the processes. Okay, so so if the question arises like that, does this state is in a safe state or not? And you see that the process, the available resource can satisfy all the processes, that you directly write yes, the system is in a safe state. You doesn't need to check for the P0, P2 or a P4 because it satisfies all the processes, so doesn't need to check. You can run any of these three processes. So it means the system is in a safe state definitely. Okay. So if it is in a safe state, you can write the system is in a safe state. Okay. But if it asks you about the sequence, then you have to solve the question. So let's do that. Now after that, we let's say go with P0. Okay. So P0, after P0, what is the available? Currently available plus the allocated of P0. Currently available we have 743. The allocated to P0. P0 we have 010. We have 010. 010. So if you sum up this, you will get 753. So after P1, oh sorry, after P0, you will get 753 resource. So P3 is also now completed. P3 is also completed. Okay. Now you can satisfy, let's say I'll go with P2. So it needed 600. We have 753. So So the process is P2. P2. After completion of a P2, the available one is currently available. CV means currently, CA means currently available and allocated to P2. Currently available 753 allocated to P2. Let's check what is the value. 302. 302. So if you sum up this, you will get 3, 4, 5, 5, 10, 5, 5. You will get 10, 5, 5. So after P2, you will get 10, 5, 5. Now P2 is also completed. P2 is also completed. Now you can satisfy P4 as well. It needed 431. You can able to provide that resource. Now after P4, what is the value? 1055 currently available plus the allocation of P2, P4, which is 002. So if you add it, you will get 10, 5, 7. So this is our currently available resource after completion all these things. Okay. So here you can see that how is it is. So this is how, and you can write the sequence as well. Now the interesting thing in the sequence for this particular question is when you complete P1 and P2, you will have three choices. You will have three choices whether you go with P0, P2 or a P4. Either you go with P0, P2 and P4. After completing P1 and P3, you have three choices. It means one more than one safe sequence is possible for this question. More than one safe sequence is possible for this question. Now, let's calculate that thing. So, first of all, we can go with either P1, which is 1 to 2. We can, because we have 332 resource, we can satisfy this one initially at the very starting point. And we can satisfy the P3 as well. We can satisfy both the thing. It means we have two choices initially. Either we go with P1 and then P3, or I go with P3 and then P1. Okay, because you can satisfy both the process initially, so you can go either of the side. After that, we have three choices: P0, P2, P4. So it means you can go with P0, P2, or P4. So if you have three choices, do it like factorial, and you will get the answer. Similar case with this one as well, P0, P2, and P4 factorial. So if this is what the sequence is gonna look like. This is what the safe sequence is. Okay. So I hope you understand about the safe sequence. You can able to find out the same sequence. The question was like it give you a four sequence. For example, it says that P4, P1, P0, P2, and P3. So definitely this is not answer. It never start with P4. It I start with either P1 or a P3. So if our option any one of the option match, and if matches, then correct. That option is a correct. Okay. So this type of a question are asked in a your college examination as well as in a gate examination. Okay.